All right, so we are looking at section 3.5 in our textbook, in our student journal rather. It's on page 68, and we're going to be looking at how to solve systems. These systems are going to be nonlinear system. A nonlinear system just means what it sounds like. It's not a line. It could be a quadratic, which is what most of ours are going to be that we're looking at. So one method we have for solving systems is by graphing. When we see to solve the system by graphing, we're going to use our graphing calculator. Anytime in your book it says to solve by graphing, we're going to use our graphing calculator. So on the first problem, we're not even going to need to use this. We're going to go to y equals, clear out anything we have. Check your stat plots, make sure they're not on. If they're highlighted, they're on. We don't want them on, so turn them off. Put in your first function, 1 divided by 2, x squared minus 3. Put in your second function, negative 4 minus 2x squared. Make sure you use a negative symbol here and not a subtraction symbol. It's not going to work. You're going to get an error message if you use a subtraction symbol. We're going to do a zoom 6 for our standard screen. Here's our first parabola, and then here is our second parabola. So when you look at those two parabolas, can you see that there's nothing that they have in common? So therefore, this is going to have no solution. We might want to say no real solution. All right, let's check out number 3 now. So we have negative x squared minus 2, and we have 4 times x plus 1 minus 3. Again, make sure that's a negative and not a minus. Do your zoom 6 to make sure you're on the standard window. Here's our first parabola, and here comes our linear function. So in this case, we have a parabola and a line. Now I can see that something's going on right here. They are intersecting, but it's too close for me to really tell. So I'm going to need to adjust my window. I'm going to make my window go from like negative 5 to 4. Let's see what that looks like. There's my parabola. There's my line. I can tell what this point is. I could find that one pretty easily, but that one is still kind of hard to see. In fact, I might need to want to go a little bit lower with my y's. So I'm going to go to my y min, make it go a little bit lower. Let's make it 15 just to be sure. My y max, though, that was way too high even. I didn't have anything happening up there. Okay, so there's my parabola. There's my line. That's pretty good. I can tell there are two solutions. And so I'm going to do second trace, intersect. I'm going to get close to this first solution. It says, is this y1? Is that your first curve? Yep, hit enter. Is this your second curve, the line? Yes, hit enter. And then one more time, hit enter. And here's one solution. Negative 1, negative 3. Now I can see that there's another solution down here that I need to find. So I'm going to do second trace, number 5 for intersect. Now if I just hit enter, enter here, I'm going to get the same solution back. I don't want that. So I'm going to go down to the other one. And I'm close to it, so I'm going to do enter, second curve, yep, enter, enter one more time, and here's my other solution. So negative 3, negative 11. And those are going to be the 2 points where these two graphs meet, and when I put in negative 1 for x, I get negative 3 for y. If I put in negative 3 for x, I'm going to get negative 11 for y for both of these two equations. And those are the only numbers that are going to make that system work. All right, let's look down here at number 4. Sometimes they give us the pictures and we have to find the solutions to the system. So I can see that right here is one of my solutions, and that point is at negative 1. Make sure you're careful with the axis. This one's going by 2's, so 2, 4, 6, 8, 10. So it's negative 4, negative 10. This point is over 2 and down negative 10. All right, so that's our solution to this one. Okay, solving this system, what's it going to be? They don't intersect at all, so this is going to be no real solution. Your back of your book may just say no solution. Same thing. All right, solve the system by substitution. Substitution means we're going to want to substitute one variable for another value. So in this case, it says y equals x plus 4 and y equals x plus 2 squared plus 1. Well, if y equals x plus 4, then over in this equation, wherever I have a y, I can replace that y with x plus 4. And then just write the rest of the problem. So now on this, I'm going to want to simplify. So I've got x plus 4 equals, square this out. You should know this. It's not x squared plus 4. Do not put that. This is x plus 2 times x plus 2. It's like this. You've got to FOIL the whole thing out. So it's x squared plus 4x plus 4 plus another one. I need to get it set equal to 0. So I'm going to subtract x. So I'm going to have x squared now plus 3x. This is 5, and I'm going to subtract 4. So I'm going to have plus 1. So now looking at this, I can see that this can't be solved by factoring. Excuse me. There are no numbers that will multiply to be 1 and add to be 3. So I'm just going to double check this. We could have made a little mistake somewhere.
Hi, I really need a custodian to take lock cutters off in the A209. A young man needs to get to his practice and he cannot get in his locker.
All right, so we can see that there actually are two solutions to this. So the solutions must not be actually, excuse me, whole number answers. So another way that we can solve that we've learned is that we can use the quadratic formula. So we're going to need to use the quadratic formula to be able to find those. So here's my A is 1, B is 3. I'm going to do X is going to have to equal negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So we're going to have negative 3 plus, that's going to be 9 minus 4 is 5 over 2. And we're going to have negative 3 minus radical 5 over 2. Remember, both of these are over 2. So maybe a better way to write our solution then would be negative 3 over 2 plus radical 5 over 2 and negative 3 over 2 minus radical 5 over 2. So now to find out what y is for this point, I'm going to have to go over here, give us some room. So my first point is negative 3 over 2 plus radical 5 over 2. That's my value for x. Well, y is always going to be this answer plus 4. So I'm going to have to take this answer and I'm going to have to do negative 3 halves plus 4. So that's going to give me 5 halves plus radical 5 over 2. So there's one of my points. My other point's this one. To find the y value that goes with that x, I'm going to have to substitute it in. So I'm going to have negative 3 halves, and I'm going to have to do plus 4 again. So that's not going to change anything. It's still going to be 5 halves, but this time minus radical 5 over 2. So those would be our two solutions. So we had to add 4 to this because these are like terms, and then I had to add 4 to this. So those are our two solutions for that. That's a pretty tough problem. The first thing we ran across was this problem, and then also the fact that we had to add 4 to it made it a little trickier. We definitely wouldn't want to plug in here. That would be even worse. Okay, I can check this now. Watch how I can check this. So I think one of my points then is negative 3 halves plus radical 5 halves. I think that's what my x-coordinate is, okay? And I think this is what my y-coordinate is, but I'm just going to keep in mind this x-coordinate. So what I'm going to do is I'm going to go back here and I'm going to check this. I'm going to put in y equals x plus 4. And I'm going to put in this one. All right, I'm going to graph it. And we think that they're supposed to intersect at that x value that I told you about. What was that again? Negative 0.38. So now we're going to see if that is the case. I'm going to do second trace, calculate, intersect. I'm going to get close to it. And we get negative 0.38. So I know that that is correct. I could check the y value too if I wanted to. But if x is correct, most likely y is. Let's check it just to be sure. 3.62 is what it should be. 5 halves plus radical 5 halves 3.62. Perfect. Okay, so we know that's correct. All right, tough problem there. Let's get to an easier one. Solve by substitution. We've got x squared plus y squared equals 16. Here's what y equals. So I'm going to have to substitute that y value in right there. So I'm going to have x squared plus, for that circle, I'm going to plug in negative x plus 4 squared equals 16. So this is x squared. Negative x squared is x squared. See, I'm thinking of it like this. Negative x plus 4 times negative x plus 4. Negative x times negative x is x squared. On the outers, I get negative 4x. On the inners, I get negative 4x. So that's going to be minus 8x. 4 times 4, I've already done that, is 16. So here's what I've got. So I'm going to have 2x squared minus 8x. And these are just going to give me 0 when I subtract from both sides. To solve a problem like this, I factor out a 2x. I'm left with x minus 4. Solving this, I set this equal to 0 and this equal to 0. So if I have 2x equals 0 and x minus 4 equals 0, divide by 2, add 4. So there are my two values for x. So I know one of my points is 0, comma, my other's 4, comma. I plug it back in the easiest spot. So this place isn't as easy to substitute in as this. So I'm going to plug in 0 here. 0 plus 4 is 4. Negative 4 plus 4 is 0. So those are going to be, that's going to be my solution. Okay? Right. So hopefully you understood that. Like I said, number 6 was much more difficult than number 7. But I really hope that you'll go back, if you didn't understand this the first time I explained it, that you'll go back and watch the video and try to figure out, or rewind rather, and figure out what you don't understand with that, because this is something that is really, you know, kind of challenging, but it's something that you'll be expected to be able to do next year in pre-calc. All right, let's go over to page 69. We are trying to solve the system by elimination now. That's our third method. We've talked about graphing. We've talked about substitution. Now we're doing elimination. I won't make you do any problem a certain way. I'll give you the option. You can do it however you want to do it, except for some of your tests may be with a calculator and some without. So you need to know how to do these without using a calculator. So I'm going to try to do this one without any calculator. So I look at what I've got y's here. If I can get rid of these y's, then I can go ahead and solve, because I'm just going to have x's. So that's what I'm going to try to do. I'm going to bring the y over here. I'm going to leave the number over here though, because see, this has a number here, but I need the y over on that side to match them up. So I have x squared minus 7x plus 11 minus y equals negative 1. This one is negative x, I'm going to line them up, plus y equals negative 4. So now I'm going to add them together. That's what we do with elimination. So I've got x squared minus 8x plus 11, those cancel, equals negative 5. Add the 5 over, x squared minus 8x plus 16 equals 0. I'm going to factor this out. This is going to be x and x, 4 and 4, minus and minus. Check it. Yep. So x equals 4 is our solution. It's actually a solution twice, but we don't really care about that. We just know it's going to be at 4. So now if I plug 4 in anywhere I want for x, here would be the easiest. I have negative 4 plus what is negative 4? Well, that's going to be 0. So what that tells me then is that this line and this parabola are only going to meet in one spot. And that one spot that they meet at is 4, 0. All right, let's do number 10 by elimination. Well, if I look at these two, I can just go from right here. So what I'm going to do is I'm going to multiply the bottom one by a negative, because then when I add them, I'll get the y's to go away like I want. So those cancel out, I get 0. These are going to be 8x squared. This is going to be 14x, and this is going to be 21. All right, so now I'm going to have to try to factor this. Numbers that multiply to be 8x squared are 4x and 2x. Numbers that multiply to be 21 are 7 and 3. We're just going to see if this will work. 7, 3. Doesn't look like that's going to work. It's not looking too good for this one to work out for us, factoring wise. One way I can check it is I can multiply these two together and see if any of their factors would add to give me 14, and that's 168. So numbers that multiply to be 168, they're going to have to be kind of close together. Let's see, 4 and 42 too far apart. 8 and 21. Okay, those aren't going to add to give me 14. Let's see, I'm going to do a factor tree here to help me. 4, 2. Any combination here, would it work? 24 and 21, or 24 and 14? No. Okay, so this is not working out so well. So what we might want to do is use the quadratic formula again. But let's just check and see where these are going to intersect, what kind of answer we're going to get. Because if I'm going to get an irrational answer, then I know that I'm going to have to use the quadratic formula anyway. I'm going with what I originally had here. So here's my first parabola. Oh, and here's my second parabola. All right, so what does that tell us then? There's no solution, is there? Okay, so that explains why it wouldn't factor. What I would do though, if this were a test and I could not use this to check that, is I would start using the quadratic formula. Negative b plus or minus the square root of b squared is 196 minus 4 times 8 times 21 all over 2a. If this under here is a negative number, then I know that I have an I in my answer, which means that there's no real solution. So all I really care about is multiplying this together. Well, even if this is 32 times 20, 32 times 20 is what? 32 times 20, 640. So 196 minus 640, that's definitely going to be negative under there. So if I had just looked at this from the beginning, this under this radical here, I would have known that because that's going to be a negative number, there's going to be no real solution. So check that. So if you can't factor, you try the quadratic formula. If you get something under here that's negative, we know it's going to be an imaginary solution, so that means we have no real solution, and it means that they do not intersect. Okay, consider the following system. It says, which method would you use to solve the system? Explain your reasoning. All right, so if I look at this, I've got an x squared and an x squared. I've got an x and an x. I would work with this first. I want to just see what happens here with this one. I can subtract x from both sides, and I'm going to get this. So my other one is going to be this one. So if I look at this, I can't use I'm not going to be able to use substitution very easily at all. Substitution is going to make it really tough because I have to solve for y, and it's too tough. I'm going to have to just use elimination. So I'm going to rewrite this one as x squared plus y squared equals 9. See what I'm doing? Just moving this over. I'm going to rewrite this one as negative 2x squared plus 2y equals 7. Now, if I look at this, it looks like I can't really do it, but I can. Because if I multiply this top one through by 2, I can eliminate my x squareds. So watch. I'm going to have 2x squared plus 2y squared. I'm going to leave a little spot for this one, equals 18. So that's what I get when I multiply this through by 2. This one doesn't need to change. It's negative 2x squared. And then plus 2y, there's no like term there, so it stays by itself, equals 7. So here's what I've got. Oh, you know what? And it just says which method would you use? And I'm going to explain my reasoning here as I just start this problem. I'm not even going to have to finish it. These cancel out. I'm going to get 2y squared plus 2y equals 25. This I can solve if I just bring this over here. It doesn't say we actually have to solve it. We're just supposed to explain what method we would use. So the best method to use on this one would be elimination, because x squared terms can be eliminated. So once we got it down to here, we could solve for y, get that answer, plug it back in to find out what the x is. It's still a tough problem, but we could do it. And then it said, would you have used a different method if the system had been as follows, and explain. All right, so let's look at this one. X equals 9 minus y. Here my x's are going to cancel out. And I'm left with 2y equals 2x squared plus 7. So what do you guys think on this one? Are you going to use elimination still? I probably wouldn't. You could. I mean, elimination isn't horrible. You could bring this y over. You could. You know, you could use elimination. But because I have x equals 9 minus y, I can just substitute in immediately for that x. So I might say I would use substitution here because x is already solved for. See, back up here, it's really difficult to solve this for y and use substitution. But here, they already told us x equals 9 minus y, so you can just plug in 9 minus y here. All right, last one here. The sum of two numbers is negative 5, and the sum of the squares of the two numbers is 17. What are the two numbers? So I'm going to call my two numbers. I'm going to say x is my first number, y is my second number. And then I have to write equations. So the sum of the two numbers is negative 5. So that tells me that x plus y has to equal negative 5. The sum of the squares of the two numbers, so x squared plus y squared, must equal 17. What are the two numbers? All right, well, I think on this one, I can't use elimination because nothing would eliminate no matter what I do. So I'm going to have to use substitution. I could use graphing if I solve this for y equals. Okay, solving this for y equals would be pretty tough though. Let me show you how you would do it. To solve this for y equals, it would be y squared equals 17 minus x squared, and then I'd have to take the square root. So it would be y equals plus or minus the square root of 17 minus x squared. Solving this one for y, it would be y equals negative 5 minus x. So if you want, you can do this. Let's go ahead and just do this on the calculator. So I'm going to put in my -5 minus x. For this one, I actually have to put in two functions. I have to do the square root of 17 minus x squared, and I have to do negative the square root of 17 minus x squared. Oops, 17, not 16. Okay, I'm going to do a zoom 6. See how it looks. There's my line. There's the first part of this one, and then there's the second part. Okay, so I can see that there are 2 points of intersection. It's a little bit difficult to tell where they are. I'm going to try. Okay, so I'm going to do second trace, calculate, intersect. I'm going to try doing this top one first. So get up there close to it, enter, oops, hold on, that's not what I want. So I'm going to go enter, I want that one. Now I don't want the top one, I want Y3 actually, so I'm going to arrow down to tell it to use this one. And push enter again, and then enter one more time. Yep, there we go. So -4, -1 is going to be one of my points. That's going to be one solution. Okay, and then my other solution, second trace, calculate, intersect. I have to arrow, get down here close. Is Y1 my first curve? Yes. And now it says is Y2 my second curve? No, it's not. I have to use the Y3. So I arrow down to get to Y3. That's the one I want. So I'm going to push enter again, enter one more time, and -1, -4. So those are going to be my two numbers. So I can use, really that's kind of the same thing. It doesn't really matter. This is my first number, this is my second number, or vice versa. Okay? Now, if I wanted, I could have solved this with substitution, like I said. Let me just do this real quick for you. I'm going to do it very quickly. So I'm going to substitute in. I got x squared plus, here's my y, here's my y, -5 minus x squared equals 17. So now I'm going to have x squared plus, -5 times -5 is 25. Then I'd have, let's see, I would have plus 5x and plus 5x, so plus 10x, and then plus x squared equals 17. So getting this simplified, I'd have 2x squared plus 10x, taking this over, plus 8 equals 0. So then I'm going to have to divide by 2, x squared plus 5x plus 4 equals 0. I'd factor x, 4, 1, plus. So right there we go. X is going to be coming down here, -4, and x is going to be -1. So that's what we got here, and then we would have to substitute back in. So if x is -4, -5 minus -4, that's -1. If x is -1, -5 minus -1, that's -4. And so that's how we go. You do it either way. All right, so again, three methods. Number 1 is graphing on the calculator. Number 2 is using substitution. Number 3 is using elimination. You have to decide which method is the best.